Welcome to the Build Conference. I'm Sridhar Madhugiri. I'm a principal developer on the Visual C++ team in Visual Studio. I'm here today to talk about optimizing your build using Visual Studio C++ 2015. So let's talk about two big areas. One is let's talk about developer productivity for C++ projects as it relates to build times. And then we'll go over some of the features we have in Visual Studio 2015 to speed up the builds. So developer productivity is key. As a developer, we go through the edit, build, and debug cycles multiple times a day. And the build time during these cycles is pretty significant for C++ projects. And a key goal for us during Visual Studio 2015 was to try to reduce this build tax in the cycle so that developers are productive and you can see large developer gains across your teams. So let's go and talk about some of the features we have for Visual Studio 2015. The first feature I want to talk about is incremental link. This is a feature that's been there for quite a few versions in Visual Studio, and we have made some enhancements to this feature. We analyzed the failures using telemetry data, and we noticed that we were missing a few corner cases, which we have gone and fixed, so that when you make changes that hit these corner cases, you don't need to do a full link. You can get incremental link. The largest failure was due to static libs. Large projects typically have multiple static libs that they build, and then they build a binary using those static libs. As a part of daily activity, when a developer touches a static lib, we would give up on incremental link and go to a full link. And the difference between incremental link and full link for these projects were quite significant. We saw some projects that take 4 minutes to link for a full link, but incremental link was 30 seconds. So if you touch a static lib, although the change that you made to the static lib would not require a full link, just because you changed the static lib, we just gave up on incremental linking. So we have fixed that, and so if you make any changes to a static lib, we can now try to do incremental link, and we have seen quite a few internal games projects that are now linking in 30 seconds, whereas earlier they took 4 minutes or more to link. So that's incremental link, enhancements to existing features. The next one is template processing. With modern code, the use of templates has increased quite a bit, and we expect that in the future that's going to increase significantly. And as we are working through conformance features for templates in our compiler, we also looked at how we process template code and made significant changes in the way we deal with that. As a result of all of these changes, we see some big speed ups in template processing. Based on the project size and the contents of the projects, we have seen anywhere from 50% speed up to 10x speed up in those extreme cases where the source file has a lot of templates. The third feature is about PDB processing. PDBs contain debug information, and for any good debugging experience, you need to have the PDB available to you and up to date, so that you are productive during the debugging experience. What we noticed as we analyzed our build cycles, where PDB processing took some significant time both during compile and link, and we root cause the reasons for this slowdown, and we have fixed those issues. So all these, the first three features I'm talking about, you get automatically as soon as you upgrade Visual Studio 2015. If your project is already using incremental link, you should see some speed ups. If you have template heavy code, automatically you should see some speed up there as well, and PDB processing is across the board. The next 4 features are features that are new to Visual Studio 2015, and you have to change your project settings to make use of them. The first one is still related to PDBs, something that we call debug fast link. The way, let's talk a little bit about how we generate the PDBs. When the compiler compiles the code, it generates a PDB, which we call the compiler generated PDB, or if you use the Z7 switch, it puts the debug information into the object files. And then we link all of these object files. As linking is happening, the linker is also extracting all the debug information that is required for the final binary and putting it into a linker generated PDB. When we analyzed the time that was spent processing PDBs during linking, it was all related to extracting this information from these various sources and putting it into one file. For large projects, that can be quite a bit of data. We have seen games with more than 1 GB PDB files, and all that takes quite a bit to process. So we came up with this new feature that allows you to speed up links significantly without affecting your debug experience. So the change here is that when linker starts and you have this new switch specified, the linker keeps the debug information in the compiler generated PDB or the object files. It then generates a PDB that has links to these PDBs and object files, and it then puts in information that only it can generate. And so the PDB processing is now significantly sped up. In some linking situations, we have seen PDB take up to 50% of the link time, and for those projects, it's now the PDB processing is very small. It's more like 5% of the total link time. So you get some significant speed up, and then when you start your debugging session, the debugger knows that this is a different type of PDB. It can go get the debug information from the location where that is available at, either the compiler generated PDB or the OBJs, and then it'll give you all the debug information. You don't have any loss of fidelity during debugging, neither is there any performance impact in the debugger. So that's the first feature that you can use by changing your project settings. The next one is a switch to the compiler called ZC No Inline. This switch results in the compiler generating fewer symbols, and essentially then the linker has less to deal with and can speed up links significantly. So what happens with this switch is any function that's marked as inline but not referenced in the compilation unit is essentially there is no code generated for it, and it's as if the code wasn't present. As a result, we have seen that static libs and OBJs are about 30% smaller, and the speed up we get from in the build is due to 2 reasons: less I/O because of the smaller sized OBJs, and then our static libs, and linker is sped up because it doesn't need to deal with all of these symbols that are not referenced, and it then doesn't need to worry about throwing those symbols away. So that's a speed up that you can see with this switch. There is a potential for breaking some of the existing sources as a result of using the switch, but using the switch gives you more conformant code, and fixing the issues is trivial. We have some blog posts that talk about how to address these on our blog site. I'll talk about the location of the blog site later. The next feature is link time code generation. Link time code generation has been there for multiple versions, and some people use it and they complain about the build times. Other people have stopped using it because of the productivity hit in the build. We added a new feature here, which we call as fast link time code gen, and the idea here being on the first build, the optimizer saves away information about the analysis it performed as well as the code it generated into a database. On the next build, after you have made some changes to your code, when you start the build, the compiler figures out that there is the database from the previous build, picks up all the information from there, does analysis to figure out the delta of what needs to be regenerated. It regenerates code only for the parts of the binary that are impacted, gets the rest of the code from the database. It queries the database for all the information from the previous build and then generates the binary. The end result is a binary that has the same optimization level as a binary that you would have created if you did a clean build. And the binary is also a shippable binary. That is, it does not have any artifacts in it that would sort of more debug information or some additional padding in the binary, or any such artifacts are not present in the binary. So it is a shippable binary. We have been using this feature internally from the time it's come online for about 6 to 9 months, and we see about 4x improvement in our build times, because we use link time code generation on our binaries, and every developer, when they build, typically they use the link time code generation to build their binaries, and a 4x improvement for most of the changes that we make is a significant developer win. So the new fast link time code gen switch not only now allows you to get the performance gains in your application, but also brings the productivity in this area. The last topic I want to talk about is an extension to the IDE to analyze PCH. So PCH is a mechanism by which we can speed up compile times. This mechanism is used by different compilers, not just Visual Studio, and we see significant speed up in build times as a result of using PCH. One of the things we noticed was that PCH goes stale very quickly. As changes are made to the project, new headers are required to build a project, and typically those headers don't end up in the PCH that could, when it's quite possible to put them there. So this extension is our first step in sort of analyzing your code during design time and start giving you hints about making changes to your code to improve your build times. Yes, there are other analysis tools that give you details about your code or how to improve your code, but this one is the first time we are trying to do something that can help analyze your project to speed up your build. So the way to use this is go to the Visual Studio gallery, search for the PCH analysis extension, and then download and install it. Once you have it there, you should start getting hints about changes you can make to the PCH to speed up your build times. Currently, the PCH only, this tool only analyzes the PCH for files that could be included in it, but I can definitely foresee us making enhancements to also detect cases where a file that should not be included in the PCH is included, or files that are only required for a certain configuration end up in a if-def block that can be used only for the configuration and not have to slow down other configurations. So these are some of the great features. Some of these features you get for free as soon as you upgrade to Visual Studio 2015. Others, you had to make some changes to your projects to get those features. We are updating our Visual Studio templates to sort of give you the best build times for that configuration, but if you have, for your existing projects, you have to go and apply some of these manually. Let's talk a little bit about future. Yes, we have done some analysis right now, we have sped up a few things, but what are the key things that we think in the future are going to help with speeding up the build times for C++ projects? The first one is the C++ modules proposal that the C++ standards committee is looking at right now. This proposal has multiple advantages. One of them that I'm going to focus on here is the potential for this modules feature to speed up build times. Today, when you include a header file, we have to transitively include all the header files that are required in every compilation unit. PCH helps with that a little bit, but you have to include all of them. Even for types that are internal implementation details of a class, let's say, you need to include headers that satisfy that types. So the C++ build model requires us to include a lot more headers than necessary. Modules can help us because it helps us encapsulate implementation details away from the end user in a much better way. We think it also has now the potential of speeding up builds significantly, and multiple compiler vendors are looking at this feature, and they are also discussing this actively in the C++ standards committee. So that's one of the features that we think will make a big impact. The other thing that we noticed was the build analysis tools. We have tools to do static analysis, but we don't have many tools to help you figure out where time is spent in a build or changes that you can make to your project to improve build times. Our PCH analysis tool is the first step. We expect to add more in this area to help you find those bottlenecks and start addressing them. So basically Visual Studio 2015 gives you a lot of these features, and so the first thing I would say is go download 2015, install it, try out these features. Some of them you get for free, others you have to make changes to your projects. For a lot of this information, we have blog posts for some of these features already on our blog site. Other features we are going to talk about in future blogs. So definitely visit the VC blog site to get more information about these features and as well as other features that we have in Visual Studio 2015. So thanks for listening to my talk, and hope you have faster builds using Visual Studio 2015.